This is FEA assignment 2 part 1. So in part 1 we're doing the numerical comparison of CTS to Q4 with element model and element defect. So in part 1, going through the question, I'm getting the information with the load at the end of the beam is 2000 Newton, the length of the beam is 100 mm, the height of the beam is 20 mm, thickness of the beam is 5 mm, and the elasticity is 200 GPa. The Young models, So for the moment of inertia, I equal to 3.33 times 10 to the power of -9. So the I was find by myself. It's not given with the question. So by running through the FEA, Lisa FEA software, with this Q4 2 rows and 10 column, the element model, I'm getting the result, which this principal stress and the displacement is what for the analysis in this task. So also the CTS type 1, type 2 and type 3. So the only difference with this type is the element model pattern. And after getting the information, I compute it into the tables. So this table show all of the maximum principal stress and the maximum displacement for each element model. And also here the classical beam theory is calculated by the analysis theory and getting the theoretical result. So this error comparing for Q4 and CTS compared to classic beam theory. So we can see the error of maximum displacement is 100, which means it's totally not matching. So this model for quad 4 is the model. Then this the CTS type 1, which the arrow is going their side, and then for CTS type 2, the arrow is the opposite direction, and then for the last one, CTS type 3, is a diamond shape in the model. So for the discussion, the arrow for the maximum displacement comparing to Q4 and CTS result with classical beam theory are 100%. This could also the error where is 100%, say this could be due to the load is undefined in Lisa FEA software. So by running through the apps, you can know you insert a new load and then you don't know what's the load value. So this could be the problem why the maximum displacement having the 100% of error. So the moment of inertia is getting from the formula. The formula is classical beam theory formula, which the base time height of 3 times 1/12. By look through the result of Q4 and CTS, it can be seen the value of CTS getting closer to Q4 value. So the CTS value from type 1 to type 3 is getting closer to quad 4 value. Yeah. So this tells the pattern of a type of element model could affect the result. So for CTS type 1 has the highest stiffness according to the result. So CTS type 1 have the higher stiffness is because it has the lowest maximum displacement compared to all four types of the element model. So for the conclusion, I will say the result of FEA software analysis will probably differ with the theoretical analysis, which the difference could be predict. This say so the difference could be predict for those who are more familiar with this subject, or you can more program more better for the FEA software, so you can get a more accuracy answer to the classical beam theory. So for Q4 and CTS type of element model, their result was slightly different, but with CTS type 3 is almost having the same result with Q4. So by adding more column to the result, it should be getting more closer to the Q4 value. So the CTS in the CTS type 3, maybe you add more column in the element model, the result will getting closer to the Q4 value. As a conclusion, Q4 is the more simple element model, also the closest value compared to classical beam theory. That's all. Thank you.